Guys, today I'm back with another demo. Today's demo is a motion detection bulb, and we are going to be using a PIR sensor here, a mini PIR sensor to be precise, the HC-SR505. And what it basically does is, it's a small sensor. What it does is it checks the change in the infrared environment. It detects motion basically. So like a human, when a hot body passes by it, it will give us a high output. It's a simple digital sensor, and if no motion is detected, it gives a low output. And this has a fixed delay of about 8 seconds, which means that after the output goes high, it will stay high for 8 seconds. So let me just break down what the circuit is. So going first and foremost to this small breadboard here, this is the sensing state. So the SR505 has 3 pins: the VCC, which is 5 volts, the ground, and the digital output, high or low. That high or low output goes here to this simple inverter stage, which consists of a NPN BJT, the classic BC547, and the output goes in through a 1k gate resistor for current limiting to the base, and the collector is pulled up with 10k, and the emitter is grounded. So basically, when no motion will be detected by the PIR sensor, the output will remain high, and when it detects, it will get grounded due to the nature of the BJT switch. And this collector output goes here to this bigger breadboard, and this is, it may look big, but it's actually just a simple 555 circuit in the monostable mode, the monostable multivibrator. So I've designed it to give a 11-second width after the pulse is detected. So basically this collector output is going to go to the trigger of this 555 here, and the trigger naturally, since it's connected to this collector and it's pulled up, the trigger in the monostable mode will only activate the output, which means the output of the 555 will go high once the trigger gets grounded momentarily. But since it's pulled up, normally the output will be low. So as soon as the flow will be such that as soon as motion is detected, it will go here to this BJT. The BJT's collector, which is normally pulled up, will get grounded through the emitter. That grounding will affect this trigger input, which, since it gets grounded, the output of the 555 is going to go high. And that high output, now if you could also use a LED, but in this case I'm using a bulb. But the output is now going here to this small black mysterious device. It's not a mysterious device, it's just a solid state relay, a SSR as they call it. Normally we would be using a electromechanical relay, but those always, since it's electromechanical, it's gonna have wear and tear, it's gonna break down eventually, not of course not normally, but it has wear and tear, and again it has its own tolerances due to the coil. And the another problem is you need to add a diode, since there'll be a back EMF after the current gets disrupted when it goes off. So SSRs are nice devices which don't even have a noise, since they're not electromechanical, they're purely electrical switches. Internally it's basically just a photo transistor and IR LED. So as soon as the input signal, and this is a 5 volt SSR, so once you give 5 volt to it, the output is going to get connected, and you can do whatever. You can switch a AC load. That's what mostly relays are used for, AC loads like this. So yeah, coming back, once the 555 output goes high, that is going to go to our SSR through another small, we need a NPN because we need some current to drive this. The output of the 555 can't directly drive it. So a similar inverter stage like what you saw here, the output of the 555 is going to go to the base via another same 1k resistor. The emitter is grounded, and the collector is connected to the negative of the SSR, and the positive is permanently connected to VCC, which is same 5 volts. So as soon as the output goes high of the 555, the output of the collector is going to go low, which is normally pulled up, and that negative is going to connect to the SSR, and the SSR is going to turn on. And on the output here we have these wires. One is connected here to the AC. We have live and neutral. That live and neutral is just via these WAGO like connectors, as they call it. Is basically just a simple connection that such that once the SSR turns on, the bulb will turn on. So enough of the enough of my talking. I'm going to just show you a demo now. Let me just switch on the circuit. Okay, I have powered on the circuit. The AC is turned on and the battery is connected. And I forgot to mention, this is a simple 7805, which will give us a fixed regulated 5 volt output from this 9 volt battery, which is used throughout for the sensor itself, for the 555 and the SSR. So all three of them. So now I'm just gonna move my hand through this PIR sensor and you're gonna see that the output is gonna go high. Let me just focus for 1 second. Yeah, so now let me just pass my hands through this. You can see that the output went high, and since it's for 11 seconds, it's going to be high for about 11 seconds. So it's been about 6, 7, 8, 9, 10, 11. Perfect. So the better timing resistors, lesser tolerance, and the capacitance which you use, you're going to get almost perfect timing. The 555 is very robust. Once more, if we just want to see it. Oh, that's another thing. It may trigger very quickly because this Fresnel lens gives it a 120-degree angle. So it's like you could imagine it like this and that way. So you need to be a bit careful where you place it. So it's still high. Now it went high again. It will be high for about, yeah, 11 seconds, the same. Now once more, if I do the same thing, oh, I moved again. Yeah, it's the same thing. So yeah, I hope you understood how the simple circuit works. And another the charm of this circuit, it's there's no MCU involved. It's fully discrete, so just like the old times. So yeah, it's nice. Thank you.